Welcome to a short film about thin films. Today we are going to be exploring thin film interference and how these thin films can actually generate colors at the nanoscale with small variations in the structure. So today we're going to kind of be first looking at the colors generated by beetles and butterflies actually, and how they generate these iridescent beautiful colors that we see in these natural ecosystems. So you can see here the iridescence of these butterflies, and we're going to kind of do some initial tests to understand how these colors are generated and why. Thin soap bubbles can actually have thicknesses on the order of about a wavelength, and with these structures you can actually see different colors in this bubble. You can see different colors in this bubble actually originate from different thicknesses of the bubble. So light incident on this bubble gets reflected off of the top surface of this kind of soapy layer, and then the light that's transmitted through can also reflect off of the back surface. And so you have essentially two light waves that can interfere off of this bubble surface, and based on the thickness you can get thin film interference. So these beetles actually use thin film stacks of different refractive indexes. And what these stacks are able to do is the beetles can essentially select or essentially evolved in such a way that they can blend into their environment, or through sexual dimorphism, they can essentially create different colors to either differentiate the different genders of these beetles or kind of blend into their environment. So if we take, for instance, a beaker of isopropyl alcohol, which has a very low surface tension, which allows it to essentially wick into extremely small areas, what we can do first is we can actually drop this isopropyl alcohol onto these butterfly wings. The result may surprise you. So what we find is actually when we drop this isopropyl alcohol onto these butterfly wings, the butterfly wings lose their color. The reason for this is because the color in these butterfly wings is actually generated by a nanostructure. These nanostructures almost look like little Christmas trees. And what they do is they refract and bend light in a specific way so that only the blue color is reflected, and every other color is actually transmitted and absorbed by a black backing in the butterfly wing. So you can see here on the right side we have the unaltered nanostructure, but as we surround the nanostructure with a refractive index matching that of the wing, you can see that the wing actually loses its color. So you can see how these natural systems, these natural animals, are actually using this technique of thin film interference to be able to engineer how light interacts with their shells. And we can actually use this in the research that we are doing here to be able to engineer light matter interactions.